Triangles, part 2. All right, we have a slight variation in this one. The previous one, I was just using CL. And I had to wait for a temporary dipole. Remember that? Well, I don't have to wait for a temporary dipole this time because of 3.0 for CL and BR. What's your guess? 2.8. Yeah. So which one of those is always slightly positive? BR. Which one do you attack? The positive one or the negative one? You're attacking with electrons. Positive one. So you don't have a choice and you don't have to wait. There's the 2 arrows that you always do. Third arrow from the lone pair on the atom you attacked. Back to make a triangle. Which carbon do you come back to? More or less substituted? More substituted carbon. Get used to that answer. Whenever I ask the question, it's going to come up again in the same mechanism. Whenever I ask the question, which carbon do you attack? You're just going to keep saying the more substituted one. Okay? Helps you remember, right? So I brought the lone pair back to the more substituted. I made a nice triangle. I only need one of them. I'll go with a dash dash. And you got the methyl here and the plus up here. And notice you don't need the lone pairs on the BR. And you made Cl minus, correct? Oh my goodness, the product has an error in it. I just noticed now. Please edit your product. It is wrong. Oh, edit your product. Those need to be flipped. The Cl attacks which carbon? I did ask it right now. More substituted, which is tertiary in this case. So yeah, I had a BR there, didn't I? It was wrong. And BR here. Fix your product, please. Backside attack on which carbon? More substituted carbon right here. Backside of a dash is a wedge that accounts for that product, doesn't it? That's a terrible arrow. It's a very simple mechanism, isn't it? It's not bad. Explain why the bromine must be attacked by the alkene and less electronegative. How about just doing it this way for your answer? 2.8, 3.0. How's that for an answer? You're clearly talking about something. And if you give me the right numbers, you don't even have to tell me what the something is. That's my deal with you. We attack the more positive atom always, right? If you're less electronegative, you're more positive. And why does the chlorine attack the more substituted carbon in the triangle in the final step, which we just did? Here's your answer for that. C. It's outside of the mechanism, so C. Cl minus attacks the C that spends more time as a cation due to hyperconjugation. So that is kind of an awkward sentence that's better described with a diagram. Here is the molecule that we're talking about. It's got 2 more resonance forms. None of them as good as the first. None of them as good as the first. That's what my arrows are showing. One of them looks like this. And the other looks like this. So we have the most stable And the reason it's most stable, it is that it doesn't have any what? No OV. OV, OV. Now, of the two OVs, which one is a better cation? But more hyperconj, right? Hyperconj. That's short for, well, it's a new word. I shouldn't short form it at all for about a week. Hyperconjugation. So that's why we go to the more substituted carbon, because it spends more time with a plus right there. See it? You don't have to show me the picture on the test. This whole exercise is to help you remember why we're doing the steps that we do. Okay? And describe the stereochemistry as anti or syn and explain your choice. The D, regioselectivity, is Markovnikov or anti. We haven't done that. We're going to do E though. And why do we ever get anti-stereoselectivity? E, backside attack, always gives anti-stereoselectivity. And we'll talk about this Russian guy in a second. D. And we'll do it on the bottom here. D. The new attacks the more sub-carbon. Can I short form substituted? No, I can't. Substituted. That's a lot of T's. C. And that explains why we have the chlorine on the more substituted carbon and the bromine on the less substituted carbon. But when we're talking about this Russian dude here, anybody want to take a stab at trying to say that word? Yeah, he said it the American way. That's okay. If you're a Russian, your V's are sounded out as W. Yeah. Markovnikov. Oh, I'm not going to test you on that. I had one student who said he liked Marco Polo, so he said, Marco, it's a Marco reaction. I don't know if he would have that accent, but good chance. Okay. All right. So what do we have? Markovnikov. I'm just going to tell you what Markovnikov is. It's very straightforward. Much more straightforward than the guy's name. The more electronegative atom ends up on the more substituted carbon. And you got to remember, when Markovnikov was doing these studies back in the early 1900s, we didn't know what a mechanism was at all. They were just observing products. And they said, oh, it looks like it keeps ending up on the more substituted carbon. Because they would compare it to known molecules that they've made in other ways or found in nature and say, oh, it's that one, not the other one. So that's all they could do back then. So they were just describing what was happening without understanding why. The mechanism is why. We do understand the mechanism now. Fully. It's been fully studied. It is this way. So, more electronegative Cl on the more substituted carbon. It's tertiary, right? Just to finish off this discussion. Tertiary is more substituted than secondary, which has the less electronegative halogen. I would like to point out that we already had an example of Markovnikov last time. We just didn't label it as such at that time. So I'm just going to go back to our previous activity right here. And I want to remind you, there's a new H up here as well. What's more electronegative, H or Cl? Cl, and it's on the more substituted carbon. You would say this is a Markovnikov product, right? And if you had to draw the minor product, it has the Cl here. That's called anti-Markovnikov, which is very unfortunate because it has the anti in it. And we use the word anti for stereoselectivity, which is a different concept. Okay. Here we have the less electronegative H on the more substituted carbon, right? And the more electronegative Cl on the less substituted carbon. They don't match. So that's just an aside for activity 2. And here's activity 2. Okay, and did we cover all these things? Regio, Markovnikov. Stereo is anti. Did we describe why? We didn't? Oh, backside attack always gives anti. We did. End of story. End of video.